Hello friends, so how are you doing today? Today we are going to talk about how to make a three-phase inverter using an 8051 microcontroller. But I'm thinking to make another video, the next one that will be the next one uh, for the same task, but the coding will be done on Arduino. But today I'm going to show you how to make a three-phase inverter, how to actually control the switching of the the different type of switches that you are using. Well, first let me tell you that actually I thought about this because I had to make a semester project of mine that was three-phase inverter, and I searched a lot about that, but I didn't get the code of it, about the microcontroller like that. So I thought I should make the code by myself, and then I started making the code, and alhamdulillah I was successful. So well, actually it's a very simple code. I was thinking that it will be a complex one, but it's not actually that one. uh, so let's get started, but before that let me tell you that this today what we are going to do is three-phase inverter is using 8051 microcontroller, 8051 microcontroller, and the coding will be done in C language. So before that, I think I don't need to tell you the whole working of the the three-phase inverter, but yeah, we just need to recall that what is it exactly like. So these are the switches. These are, you can see the six switches: one, two, three, four, five, six. I think it's clear here. Yeah. So these are the switches. Okay. So this is switch one. Well, one, three, five, four, six, and 2. Well, these are the numbers given to the switches accordingly, and now we'll have to control the switching of them. So well, you know that there are two types of modes of conduction: 180 degree and 120 degree. First, we are going to talk about 180 degree, and after that I will tell you about 120 degree. These are both of them are the same as each other, but just we'll have to understand the working of both of them. So these are the waveforms for 180 degree mode of conduction actually. So these are different gates. You can see on this side, these are the gates, six gates. Okay, these gates are actually the gates of those six switches that I have shown you earlier. So well, for each gate it will be switched on for 180 degrees, and for the next 180 degrees it will be switched off, and the same cycle will go on. And there are different waveforms for different switches. Okay, but let me tell you that this is here, it is 180 degree, and here is 360 degree, means this is pi and this is 2 pi. Okay, so well, actually what is the thing that you can see that after every pi by 3 there is a change. Okay, so we need to um make a scene, make a scenario for different, for every pi by 3 pi by 3 division. So we need to divide this 2 pi by 3. You know that this a whole one cycle, it takes 360 degrees. So here one cycle gets completed. Okay, so we need to divide this in different portions. So this is the portion. Okay, and same for this one. Okay, so but our work will be up to here, not consider this one. Okay, so I think okay, so we'll have to make a scenario for every pi by 3. Okay, uh, we'll have to control the gates of those switches using one port of a microcontroller. Okay, so the port of a microcontroller, and you can as you know that in one port, in each port of a microcontroller there are 8 pins, and we'll be using 6 of them, and the rest of 2 will not be not used, so we can either let them high or low. So I think it's better to let them low. Okay, because we'll not be using the 2 pins of them. So okay, I just forgot to tell you one thing that yeah. Okay, so 8051 microcontroller pin configuration. Yeah, because I just forgot to open that. So let us talk about it, because pins or microcontroller like this. Okay, so here you can see that this is a port of microcontroller. Okay, this is one port of microcontroller. Starting from here, this is port 1, p 1.0, 1.1, and up to 1.7. So I'm gonna use port 1. You can use either port 1, 2, or 0. It's up to you, or 3. So it's up to you. Well, I'm gonna use port 1 of microcontroller. So let's start with actually the codes like that. Let me show you the code. I have made the code already, and this is my code. I'm gonna well, I was before this I was of the view that I should make the code and then tell you everything, but I think it's okay. Okay, so what are we gonna do is well, actually I programmed this code. I just made this code in Keel software, because, but now my software is not working, so I thought to tell you the code in this one. Okay, so what are we gonna do? We are gonna start with, because okay, there are different things we need to know before starting. So one thing is, the first thing is that we should know the frequency for which we're gonna design the three-phase inverter. My three-phase inverter was for 50 hertz, because in my country, that is Pakistan, in my country, the voltage, the sinusoidal voltage that we get in our homes is having a frequency of 50 hertz. So if the frequency is 50 hertz, okay, so this was 50 hertz. Well, writing not that much, but okay, because it's 50 hertz, so let us find the time period. T is equal to 1 by f is equal to 1 by 50, and it becomes 20 millisecond. So it means that 20 millisecond is for this time, starting from here up to this, which means that for 2 pi is 20 millisecond, and but we need to switch on, but we need to set the to control the switching of the of the switches for every pi by 3. Okay, so pi by 3, to we need to divide, for every pi by 3 we need to divide this 20 millisecond by 6. Okay, so 20 millisecond divided by 6, so this will be the time, that is 3.33 millisecond. So this is the time for pi by 3 connection. Okay, so we'll be controlling all 1, 2 up to 6 switches for pi by 3, and then again for another pi by 3, that is for 1 pi by 3, and then for another pi by 3, and up to 2 pi. After that we'll make a while loop over it. So but what we need to do is now what we need to do is that we need to set the values for every switch now. Okay, let me get this one. Okay, so it was 20. Okay, okay. First of all, we need to know uh, for the first 5 by 3, gate 1 is on. Okay, gate 1 is on, gate 2 is off, and like this. So we need to give the values starting from gate 1. Okay, gate 1, 2, 3, 4, 5 and 6. Okay, let me make different portions: 5 by 3, 5 by 3, 6 portions of each 5 by 3, 1, 2, 3, 4, 5 and 6. Okay, for first 5 by 3, gate 1 is on. Okay, gate 1, gate 5 and gate 6, these are on. Okay, gate 1, 5 and 6, let us write it in this way: 1, 0, 0, 0, 1 and 1. Okay, this will be the thing. Okay, so for this we need to write that okay, but we know that here we are using 6 pins, and when we'll be using the microcontroller we will have to deal with 8 pins. So the rest of the 2 pins that are for example pin 7 and 8, but the last 2 pins we need to switch all of them off. Okay, so this way we will be controlling. And uh, if I say that this is a microcontroller and this is the port P1 of microcontroller, and these are the pins 1.0, 1.0, 1.1, 2, 3, 4, 5, 6 and 7, 1.7. Okay, and if I say for example that we have to control these switches in a way that G1 connected to 1.0, G2 connected to 1.1, G3 connected to 1.2, G4 connected to 1.3, G5 connected to 1.4, and G6 connected to 1.5. The rest of these 2 pins will be set 0 because we don't need them, and we don't want our extra power to be wasted, so we'll just switch them off. This is the port. We have given values, so let us give the values to the port. Okay, as you know that it's a byte, it has 2 bits, sorry, it has 4 bits, and this is LSB, sorry, this is high, this is high side, and this is low side. Okay, this is a port P1, support P1. Okay, and these are the pins 0, 1, 2, 3, 4, 5, 6, 7. Okay, and we need to give values to them. So according to the values of these switches, we'll give them values. G1 is 1, and then 0, 0, 0, and these 2 are 1, 1, and these are the pins. This pin is 1.6, and this is 1.7. We don't need them, we don't need to use them, so we'll set them 0. I have told you earlier why. So this is the binary value for pi by 3, binary value for first pi by 3, Okay, and we need to convert this into hexa form. There is nothing difficult. I have a calculator. It's just very easy for me to convert it. Okay, 00110001, 00110001. So it is in hexa it becomes 31. So this is the value in hexa. So we need, what we just need to do is that we need to write P1, actually it's, yeah, P1 is equal to 0 cross 31. Okay, and after that the values. Okay, this is the code. This I have told you now, that P1 is equal to 0 cross 31, and similarly for the next pi by 3, well, I'm going to show you how is this fixed delay calculated, but before that, let us talk about the values of that we are gonna give to the port. This is P1 is equal to 0 cross 23. How did this come? 0 cross 23. Okay, for the next pi by 3, gate 1 is high, gate 2 is high, and gate 6 is high. So we need to write the value in the way that 1 is high, 2 is high, and 6 is high, and the rest of them will give this value. So if we convert this thing, 001 000 11 001, so this is how it goes. So for every pi by 3 we'll set the values till this 2 pi. Okay, first pi by 3, second pi by 3, well actually first pi by 3, second pi by 3, third pi by 3, fourth pi by 3, fifth and sixth pi by 3. We will set the values up to this 6 gates. So we'll set the values here, and okay, so now comes the delay. That why are we gonna give the delay? Because we need that because we actually need to give the values to all the 6 gates. Let's say we have given the values to all the gates at this time, and we need to keep these values for about 3.3 seconds, and after that we need to change them again here at this point, and again give a delay of 3.3 milliseconds for pi by 3. So to give a delay of 3.3 milliseconds, I have made a function here. I've already calculated, and I have made a function here. This is the function. I'm gonna tell you. Just copy it and paste it here. Okay, there is one more thing I need to tell you, that on this coding that I've shown you, that this is the coding for starting from 0 to 2 pi, and here at this point one cycle will be completed. So we need to apply a while loop with a value 1, while loop with a condition 1, that it will always keep running. So due to this while 1 loop, it will keep on running. So this is the code for delay. Okay, this is the code for delay. Well, actually I think you must know one thing, that the value of when we write a for loop in yes, Okay, when we write a for loop in uh, in C language, in 8051 microcontroller with the frequency with frequency of 11.0592 megahertz, for I is equal to 0, I is less than 1275, and I plus plus. So for this for loop, what happens that a delay when this for loop runs, when this for loop runs, this one, okay, a delay of, because you can see after this for loop there is semicolon, because, which means that it will do nothing, but it will just execute an empty line. Okay. So for this for loop, this for loop, this is a for loop uh, for a delay of 1 millisecond. Actually, ideally it's not 1, it's actually 1.33. So I have calculated this using the keel and the waveforms generated through this and everything. So I've just calculated it, and this thing is for about 2 milliseconds, about actually about 2.5 or like that, and this is for additional it's trying to make it almost 3.3 milliseconds. So this whole delay, fixed delay, is for 3.3 milliseconds. So which means that we'll give a value to the port, and we'll call a delay to keep these values on the port for about 3.3 milliseconds, and then for another 5/3 this thing, and this is the code. Okay, so at this time, this will be the last value given to the port, and to keep it for about 3.3 milliseconds, here's a fixed delay called again, and this this thing is for one cycle. So we need to so we need this thing to run again and again. So we have here error function of while loop. This was all about how to make a three-phase inverter using 8051 microcontroller, and the coding is in C language. Well, this was about 180-degree connection. Same is the same for 120-degree mode of connection, and it's like it will start from here and ends up here. This is 2 pi, and this is pi. Okay, this is pi and this is 2 pi. So for every pi/3 we need to see the values. Okay, for every pi/3 we need to see the values in the same way, and in the same way we need to give the port different values. So this is in this way you're gonna make a three-phase inverter using an 8051 microcontroller, and hope so it will be quite useful for you. And I think that I'm gonna I'm also thinking that I should make another video, the next one, for the same thing but for Arduino, using using Arduino. So that was all, and I just request you to subscribe my channel, like this video, and share this video with your friends, and because there will be an importance for you, a benefit for you for this subscription, because when you will subscribe this, you will be able to receive updates from my next videos, and the next one the next video inshallah I'll make about how to make a three-phase inverter using Arduino. So till next time, just before closing this video, just like and subscribe. So thanks for watching.